Something strange is happening with the Aptera's wheel covers, and almost nobody has actually noticed it yet. When you watch the driving footage carefully, something about those wheel covers simply does not look right. The back of the wheel cover sits incredibly close to the ground even when driving completely straight ahead, and when the car makes any turn at all, that gap between cover and ground nearly vanishes entirely. At first glance, it honestly looks like a serious design flaw that simply should not be happening here. But the more you study it carefully, the more you realize something far deeper is actually going on. This is not a careless mistake made by the engineers working on this remarkable vehicle at all. This is pure physics doing exactly what physics has always done, completely on its own every single time. To truly understand what is happening here, you need to watch the available footage very carefully and closely. The rear of the wheel cover sits very close to the ground even when driving completely straight ahead. The front of the cover is also close to the ground, but it is far less noticeable overall. The reason the front looks less dramatic simply comes down to basic distance and geometry principles involved here. The front part of the wheel cover sits very close to the actual tire at all times, always. But the rear of that same cover extends much further back and away from the actual tire itself. So when the wheel angle changes even slightly, the rear end moves a much greater overall distance instantly. A small angle change at the hub creates a significantly bigger movement at the far rear tip, always. Think of it exactly like a long lever arm swinging dramatically outward at its far end, visibly. The longer that arm is, the more dramatically and visibly it swings outward from the center point. That is exactly why the front barely reacts, but the rear end drops dramatically toward the road surface. Now watch carefully what happens when the wheel slowly begins to straighten out after completing any corner completely. You can clearly see the rear of the wheel cover slowly and visibly starting to rise back up. That gap between the cover and the road begins to gradually open back up as the steering straightens. Once you see this happening clearly, you absolutely cannot unsee it ever again in any future footage watched. And if the car turned the other direction entirely, the exact same effect would still happen again. The other wheel cover would dip just as dramatically toward the road surface on that opposite side. The same physics apply no matter which direction the Aptera ever decides to steer on any road. So what is actually causing all of this behavior happening beneath the Aptera during every single turn? The answer lies deep inside steering geometry and suspension design that most everyday people have never studied before. Most people have at least casually heard the word camber mentioned during a routine wheel alignment appointment somewhere. Camber is simply the angle of the wheel when you look directly at it from the front. If the top of the wheel leans inward toward the car body, that is called negative camber. If the top of the wheel leans outward away from the car body, that is positive camber instead. Nearly every modern car on the road today runs a small but very deliberate amount of negative camber. That slight inward lean helps the car handle better and grip harder through tight corners very consistently. The more aggressively a car is driven in competition, the more negative camber the setup will actually use. Drag racers use very little camber because straight-line speed simply does not demand any cornering grip at all. Track drivers might run around 3 full degrees of negative camber for maximum grip while cornering hard regularly. Weekend mountain road drivers usually stay somewhere between 1 and 2 degrees of negative camber as their setup. So camber is something that most people in the car world have at least casually heard mentioned before. But caster is a completely different story, and most everyday drivers have genuinely never heard of it before. Caster has to do with where the upper and lower ball joints sit relative to each other exactly. If the upper ball joint sits further back than the lower one, that is called positive caster here. With positive caster, the steering axis leans slightly backward from the top when viewed from the side directly. This places the point of steering contact slightly ahead of where the tire actually touches the ground below. The result is that the wheel naturally wants to trail behind the steering axis during any normal driving. This is exactly why your car feels so stable and naturally returns to center after completing any turn. Every single modern car on the road today is built with positive caster for exactly this important reason. There are almost no real benefits to running negative caster, but plenty of very serious problems result instead. So positive caster has simply become the universal standard used across the entire global automotive industry today, worldwide. Now, positive caster also has a very interesting side effect that is directly and importantly relevant to Aptera. When a wheel with positive caster turns, the front of that wheel tends to dip downward slightly always. This happens no matter which direction you turn, because of how the steering geometry is physically arranged completely. So positive caster alone would already cause the front of the Aptera's wheel cover to dip visibly. But that is only one part of what is actually happening with the Aptera's wheel covers here entirely. There is another very important factor at play, and it is called kingpin inclination, and it changes everything. Kingpin inclination refers to how the steering axis is tilted relative to the actual tire center line itself, exactly. On most cars, you physically cannot run the steering axis straight through the actual center of the tire. The geometry of the wheel and hub simply does not allow for that kind of perfectly clean alignment. So engineers tilt the kingpin axis inward to reduce something called the scrub radius at the tire contact. The scrub radius is the distance between where the steering axis meets the ground and the tire center line. A large scrub radius creates more friction and stress whenever the wheel tries to turn in either direction. So engineers tilt the kingpin axis inward to keep that scrub radius as small as reasonably possible, always. Now, this is where the Aptera becomes far more interesting and complicated than any ordinary conventional car out there. The Aptera uses hub motors, meaning the entire electric motor sits directly inside the actual wheel hub itself. That hub motor takes up significant physical space and pushes the steering axis further away from center, outward. This means the Aptera potentially needs more kingpin inclination than any completely conventional car would ever require alone. And that greater kingpin inclination has a very visible and dramatically clear consequence during every single turn made. When you combine positive caster with significant kingpin inclination, you get a very real and visible tilting effect. The wheel itself changes its angle relative to the ground every single time the Aptera steers anywhere at all. That change in angle is exactly what causes the wheel cover to visibly dip toward the road surface. And because the rear of that cover is so long, that dip becomes dramatically and clearly visible every time. The front of the cover barely reacts at all, but the rear nearly scrapes the road during turns. This is not a design mistake at all by the talented engineers who are building this incredible vehicle. It is the unavoidable result of how modern steering geometry works on every single vehicle ever built anywhere. No matter how talented the engineers are, this behavior simply cannot ever be completely designed away entirely. The physics demand it, and the geometry enforces it every single time the wheel steers anywhere on any road. There is actually a simple way to visualize this that makes everything click clearly and immediately for you. Imagine holding a long, flat wheel cover and tilting it at a very slight forward angle slowly. The front end barely moves at all, but the far rear end swings a significant distance downward noticeably. That is exactly what is happening under the Aptera every single time it makes any kind of turn. The slight angle change in the wheel creates a dramatically visible movement at the far rear tip always. And the tighter the turn gets, the more pronounced and exaggerated that entire dipping effect at rear becomes. So, what does this practically mean for anyone who is seriously considering actually buying or driving an Aptera? On smooth and well-maintained roads, this is mostly a visual thing that does not cause real problems. The cover may get very close to the ground, but it still technically clears it during normal turns. But on rougher roads with bumps, potholes, and very uneven surfaces, the situation changes quite significantly indeed. If the rear tip is already nearly touching the ground through a smooth, clean turn already happening, then hitting any bump or dip in the road at that exact same moment becomes genuinely very problematic. That rear tip will eventually make direct contact with the ground surface and start gradually grinding away slowly. Over enough time and regular driving, that corner of the wheel cover will simply wear down and shorten. For some drivers, this is completely acceptable and honestly not a significant concern during any normal daily use. If you live somewhere with smooth roads and very light traffic, you may never even notice it at all. But for drivers dealing with rough, urban, or rural surfaces full of bumps and cracks, this genuinely matters. It is something worth thinking about carefully before deciding which wheel cover setup to actually choose at purchase. The obvious solution would be to trim the rear of the wheel cover slightly upward at an angle. If that rear tip curves upward instead of running completely flat, it would clear the ground far better. But that shape change would also reduce the aerodynamic efficiency that makes the Aptera so incredibly and uniquely special. The wheel cover is not just there for looks, it is doing genuinely serious aerodynamic work at all times. Every single millimeter of that cover shape contributes directly to reducing overall drag as the vehicle moves forward. Raising the rear tip to avoid ground contact means sacrificing some of that genuinely hard-earned aerodynamic efficiency directly. This is the classic engineering trade-off that vehicle designers face on nearly every single major development project ever. You gain something very meaningful in one area, and you inevitably give up something real in another area. Aptera is almost certainly very aware of this trade-off and has already thought through every available option carefully. One very practical solution would simply be to offer two completely different wheel cover options to future customers. One version could sit very low for maximum aerodynamic performance on smooth and well-maintained roads primarily. The other version could have a slightly raised rear profile that offers more reliable clearance on rough roads. Customers living in areas with excellent road quality would almost always choose the low-clearance aerodynamic version naturally. Customers dealing with rough roads and serious potholes would naturally lean toward the higher clearance option instead. This kind of customer choice would make a great deal of practical sense given how different road conditions are. It would let buyers optimize the vehicle specifically for their own local driving conditions and daily personal preferences. Now step back for just a moment and think honestly about why any of this even really matters. Aptera is one of the most aerodynamically efficient vehicles ever designed for regular, everyday public road use anywhere. Every single design choice they make is in direct service of that extreme efficiency and impressive electric range. The wheel covers are a huge and absolutely critical part of what makes their aerodynamic performance actually work. Open wheel wells create enormous drag because air swirls completely chaotically around them as the car moves forward. By covering those wheels almost completely, Aptera dramatically reduces the turbulence and drag generated at each individual wheel. That is exactly why those covers extend so far behind the actual tire in the very first place. That long rear section is doing real aerodynamic work every moment by smoothing out airflow behind each tire. But that same long rear section is also the exact part that dips toward the road during turns. So the very feature that makes the car so efficient is also the feature creating this real challenge. You simply cannot enjoy the full aerodynamic benefit without also fully accepting this steering geometry behavior entirely. What is genuinely impressive is that knowing this issue exists, they still push those covers incredibly and deliberately low. That decision alone tells you a great deal about their deep priorities and real confidence in this design. They clearly believe the aerodynamic gain is worth every single trade-off, and the engineering logic strongly supports that completely. Now, let us briefly talk about something called Ackermann steering, because it fits naturally and perfectly into this conversation. When a car turns, the inner wheel needs to follow a tighter arc than the outer wheel always. If both front wheels turned at exactly the same angle, they would simply fight each other through corners badly. Ackermann geometry ensures the inner wheel always turns more sharply than the outer one does during any corner. This reduces tire scrub during cornering and makes the overall steering feel far more natural and very efficient. On the Aptera, with its unique three-wheel layout and hub motors, this geometry becomes especially and critically important. Getting the Ackermann geometry exactly right ensures both front wheels work together smoothly during any kind of turn. Any real errors in that geometry would create uneven tire wear and make the steering feel very strange. The Aptera engineering team is clearly and deeply aware of all these geometric factors and every necessary trade-off. Every degree of camber, every millimeter of kingpin offset, and every caster angle has been carefully and deliberately considered. The wheel cover behavior visible in the footage is a known and fully accepted result of all those choices. That is what makes it interesting, rather than something alarming or deeply concerning for any reasonable person to worry about. What looks genuinely strange at first glance turns out to be a perfectly logical and fully expected engineering result. Wheel covers on any car are considered a normal wear item that gets scratched and worn down gradually. The fact that the Aptera's covers might wear slightly at the rear tip is not catastrophic news at all. It is simply something you would want to factor in to your realistic long-term expectations as a future owner. If the covers are made from replaceable, affordable material, replacement costs stay completely manageable for any typical buyer. And if Aptera offers multiple cover options at different clearance heights, the entire replacement process becomes even more straightforward. You could even upgrade from the low aerodynamic version to the higher clearance version whenever your own needs change. That flexibility would make the Aptera genuinely more practical for a much wider and more diverse range of buyers. Camber, caster, kingpin inclination, and Ackermann geometry were not familiar terms for most people before this kind of discussion. But thanks to sharp eyes spotting something unusual in a short driving clip, they have now become genuinely familiar. That is exactly what real enthusiasm for an exciting and different product does to curious and engaged people watching. It makes people genuinely smarter, more curious, and far more aware of how the engineering world really works. Whether the wheel cover issue becomes a real problem depends entirely on where you personally plan to drive daily. For smooth road drivers, it is mostly a complete non-issue that you would rarely ever think about at all. For rough road drivers, it is a genuine consideration that deserves serious attention before making any final purchase decision. But in both cases, this behavior is explained entirely by physics and geometry, not by poor engineering decisions at all. Knowing the important difference between those two things matters a great deal when evaluating any genuinely brand new design. When you truly understand the physics behind it, the concern fades quickly, and genuine appreciation for it grows naturally. Fear and concern almost always come from simply not understanding how something actually works in real everyday life. And deeper understanding always comes from asking the right questions about what you are actually seeing before you. So the next time you watch footage of the Aptera driving through any corner at all, watch carefully. Watch that rear tip slowly drop toward the ground as the wheel angles inward through the full turn. You will not see a flaw. You will see physics doing exactly what it has always done everywhere. You will see caster, kingpin inclination, and geometry all working together in completely clear and visible plain sight. And you will understand something about this vehicle that most casual observers simply walk completely and entirely right past. That deeper understanding is what truly separates people who just passively watch from those who genuinely and clearly see. Keep watching, keep asking the hard questions, and keep pushing every single conversation far deeper than the surface always. Stay genuinely curious, keep your eyes sharp, and never stop asking how and why things work exactly this way.